Welcome to HPC News Bytes, a weekly show about important news in the world of supercomputing, AI, and other advanced technologies.
Our first story is a group of industry heavyweights have formed what they're calling the Ultra Ethernet Consortium, Shaheen, to build an Ethernet communication stack architecture for high-performance networking. This is all geared for HPC and AI. List of founding companies very impressive: AMD, Arista, Broadcom, Cisco, Eviden, HPE, Intel, Meta, and Microsoft. Of course, Ethernet is already used throughout HPC, but this consortium's goal is to optimize it for the most data-intensive workloads. I talked with consortium organizers if this is taking aim at NVIDIA and InfiniBand, and they said no. In fact, they actually expect NVIDIA to join the consortium possibly later this year.
Oh, very interesting. Well, there's obviously already a well-established Ethernet standards body, the IEEE 802.3, that's been around for a very long time, but it seems to be focused on, and I'm now reading from their Wikipedia page, quote, the physical layer and data link layers media access control, otherwise known as MAC, of wired Ethernet, end of quote. Whether or not IB is a target, with Ethernet from below and PCIe switches from above and CXL to round it up and add functionality, InfiniBand is under attack. AWS already did their EFA, Elastic Fabric adapter. Azure already has their accelerated networking. Google has their equivalent. So this is an attempt, I think, by the industry to rally everybody else. The other news this past week was Meta and Microsoft introduced their next generation large language model, Llama 2, that is built by Meta Facebook, and they have open sourced it, not just for research, but also for commercial use. People can use this and actually make money off of it. That promises to be pretty disruptive.
Well, and it's interesting to note these large language model initiatives are popping up all over, of course, but Microsoft is a lead investor in OpenAI, the creator of ChatGPT, which set off this whole generative AI firestorm that we're living in. And now Llama will compete with ChatGPT. So there we go.
Yeah.
All right. Now on the next generation wireless communications front, NTT Corp and Tokyo Institute of Technology announced this week that they've demonstrated a phased array transmitter module to enable ultra-high capacity data transmission to mobile receivers. They say this is the first wireless data transmission via beamforming in the 300 gigahertz band, and this is expected to be utilized in 6G communications, Shaheen.
That's incredible. Getting something at 300 gigahertz requires a lot of seriously advanced tech. The challenge for these high-end communication technologies, and we saw it at 5G too, is what are the use cases and in what conditions do they work? At what distance? Will it be working if it's raining? Can you use it indoors? And can I do all of the above at the same time? But the progress has to start somewhere, and this is super cool. The next news item is about Cerebras, the AI chip company that is using an entire silicon wafer as a single chip on a 30 centimeter squared wafer. They get 21.5 centimeter squared worth of real estate. That's 2.6 trillion transistors. That transistor budget makes 850,000 cores and 40 gigabytes of memory. This is on their second generation system. So clustering a bunch of these was always in the cards. The news came that Cerebras and G42, a technology holding group based in the United Arab Emirates, have launched what they say will eventually be the largest AI supercomputer fabric in the world. They're starting with a 64-way cluster, which produces 4 exaflops of 16-bit performance, is available now as a cloud service. In general, and as usual, the interconnect and the software will be key. There wasn't enough information on that, so we have to wait and see.
That Condor Galaxy 1, they call it CG-1, has been installed at a Santa Clara data center. It's the first of 9 total systems that they plan to install. On the quantum front, Atom Computing and NREL, the National Renewable Energy Lab, part of Department of Energy, are exploring electric grid optimization using quantum. This collaboration is just the kind of optimization workload that we've heard for years is really suited to quantum computing, and nothing could be more complex with more multivariables than an electrical grid. So it'll be really fascinating to see how they progress with this.
Electrical load optimization has always been a very compute-intensive problem. So I can see how quantum computing can be promising. Now, atom computing using a trapped ion modality, using what they call optical tweezers to trap 100 atoms in a vacuum chamber. And trapped ions and atoms generally tend to show good fidelity. They keep their coherence time for a good while. There's another very good step, but again, we have to remember that the whole space is still in its infancy, so patience continues to be required. All right, that's it for this episode. Thank you, everybody. Until next time.
HPC News Bytes is a production of Orion X in association with Inside HPC. Shaheen Khan and Doug Black host the show. Every episode is featured on InsideHPC.com and posted on OrionX.net. Thank you for listening.